Hi, I'm Tanya from Biochemical Engineering and Biotechnology Department, and I'm doing my ELP101 project on a laptop charger. A laptop charger is an electronic device used to charge your laptop's battery. Laptop chargers, sometimes known as laptop adapters, are basically a type of external power supply unit. Its function is to supply power to your laptop and charge its battery. It is an AC-DC power adapter designed to accept a certain AC input and convert it into a particular DC output. The key is to match the DC output of the adapter to the DC input of the laptop. AC adapters are used with electrical devices that require power but do not contain internal components to derive the required voltage and power from mains. Components of a laptop charger. There are three major components of a laptop charger: a power cord, an AC power adapter, and an adapter plug. Inside the AC adapter, there is a transformer, four diodes in a bridge rectifier, and a capacitor to smooth the waveform. We now move on to the working of a laptop charger. The first part of the charger is the power cord. It is what connects to the power outlet in your home or offices. The current coming from the cord now goes into the adapter where it first passes through the transformer. A transformer is a device that can either step up the voltage of incoming current, that is increase the voltage from primary to secondary, or step down the voltage of incoming current, that is reduce the voltage from primary to secondary. The current in the outlet is usually at a high voltage, whereas the electronics in our laptop are designed to work at really low voltages compared to the outlets. So if this current is not converted into a lower voltage, it might fry the circuits in our laptop. The purpose of the transformer here is to convert one AC voltage to another. It converts a relatively high voltage alternating current that is supplied by an electrical outlet to a lower voltage suitable for the device being powered. In this case, the transformer converts, for example, the 120 volts AC current from a house to 19 volts for the laptop. It starts with the 120 volt coming into the primary winding. Running down the middle and outside of the winding is an iron cord with very high magnetic permeability. The current in the winding creates an alternating magnetic field in the iron with repelling and attracting forces to create rotational motion. The secondary winding wraps around the same cord. The voltage in the secondary is controlled by the ratio of the number of turns in the two windings. So if the primary and secondary have the same number of turns, then the voltage for the both is same. If the secondary has half as many turns as primary, then the voltage in the secondary will be half. Also, in this case of transformer, the primary uses very fine wire while the secondary uses much thicker wire. So by controlling the number of turns and the thickness, we can get the desired voltage. Once the current is stepped down into a lower voltage, it is fed into the next part, which is the diode rectifier. An AC-DC rectifier circuit converts the incoming AC current into DC current. This circuit is needed because the incoming current is AC, while a laptop needs DC current to function. Power companies use AC instead of DC for transmission because it is just not possible to transmit DC over long distances. But on the other hand, most electrical appliances are on DC or direct current, so this current needs to be converted into DC from AC before going to the laptop. In the figure below, the four diodes labeled D1 to D4 are arranged in series pairs with only two diodes conducting current during each half cycle. During the positive half cycle of the supply, diodes D1 and D2 conduct in series while diodes D3 and D4 are reverse biased and thus are off and do not conduct current, and the current flows through the load as shown in the figure. During the negative half cycle of the supply, diodes D3 and D4 conduct in series, but diodes D1 and D2 switch off as they are now reverse biased. The current flowing through the load is in the same direction as before. As the current flowing through the load is unidirectional, so the voltage developed across the load is also unidirectional, therefore DC voltage is generated. We now get a pulsating DC, so we use filters and regulators for smoothing the waveform. Filter circuits smooth out the pulsating current, so constant and reliable power is supplied to the laptop. The smoothing capacitor converts the full wave rippled output of the rectifier into a more smooth DC output voltage. Essentially, smoothing circuits work by storing a little bit of energy and releasing it when there is no voltage output coming from the rectifier. This reduces the ripples in the power supply. As we can see in the figure, the waveform without the capacitor is fully rippled, while the waveform with capacitor is a bit constant. This is the schematic diagram that represents what goes on inside of the AC adapter as has been explained in the previous slides. The last part of the laptop charger is the power connector. This is the device that plugs into your laptop. Thank you.